I'm Gabby Kitch. I work in Andy Jacobson's lab, for those of you who don't know me. Today, I'm going to talk about a project I submitted for publication this summer with all of these wonderful co-authors. So for this project, we measured calcium isotope ratios of dwarfed foraminifera prior to oceanic anoxic event 2, or OAE2. And we measured these samples from the classic Batticioni section from Gubbio, Italy, which, fun fact, that's where the KPG or the KT iridium anomaly was first recognized. So the OAE2 is a large-scale carbon cycle perturbation that occurred about 94 million years ago and buried a lot of organic carbon. But for this study, we wanted to examine the inorganic chemistry of the ocean with the calcium isotope system because previous studies have recognized dwarfing of foraminifera and other signs of morphologic stress, specifically on this foraminifera, R. cushmani. So we wanted to use the calcium isotope system because it's sensitive to changes in carbonate precipitation rate, and therefore we wanted to examine ocean acidification as a hypothesis for foraminiferal stress at OAE2. So we also compared this record to a new calcium isotope record generated from the Western Interior Seaway, which is here from the Aristocrat Angus core. So the main finding I want to present to you, or one of them that I want to present to you today, is that we actually see an increase in calcium isotope values, which is this left-hand panel here, where foraminifera are in this pinkish color and bulk carbonate is in this gray color, prior to OAE2. So OAE2 is marked in the geologic record as a positive carbon isotope excursion, which is in the black here. But we really see all the action in calcium isotope values going on in the lower critical interval, which is the LCI marked in this gray-green here. And if we look at other isotope systems, the increase in calcium isotope values, so again, the foraminifera from Gubbio are in pink, bulk in black here, and then the gray values are from the Western Interior Seaway, so the Angus Aristocrat core, and then a previously generated calcium isotope record from the Portland core in the Western Interior. We see that this calcium isotope increase happens in coincidence with an osmium isotope decline. So osmium isotopes really track volcanic activity, and a decline in osmium isotopes show a huge influx of mantle carbon into the Earth atmosphere. So this bodes well for an ocean acidification hypothesis if this happened relatively quickly. Again, this is all happening before this positive carbon isotope excursion that marks OAE2. And the last finding I want to highlight here is that the calcium isotope values, which is in the y-axis, correspond to these morphometric indicators of stress that I mentioned at the opening. So the foraminiferal abnormality index and the ferret diameter, which was used to show dwarfing of the R. cushmani foraminifera. So this again supports a hypothesis for ocean acidification. And if you want to hear more about this, attend my defense on November 5th.